Hi everyone, it's Miss Costa here, and in this video we're going to go through the most likely topics that are going to come up on the paper 3 for EDEXCEL Higher on the 10th of June. So like with any predicted paper, I have no clue what's going to come up on the paper. It's just my best guess based on what's come up on the previous two and what's come up in the past years. Now, it's not exactly like a past paper in that I have given more questions and more marks than would be in a normal paper, just because I want you to be as best prepared as you possibly can. So here's a list of the topics. Some of the topics I've done 2 questions for because there's different ways that they can be asked, and hopefully that's helpful. And just a little note to say that this video is made in honour of my dog Shadow, who we sadly lost 2 weeks ago. So I've kind of changed the questions a little bit, reframed them so that they involve his name, just as a little memory for him. He was just the most incredible, ever-loving, pure soul that I've ever known, and I feel so lucky to have had him in my life for as long as I did. Okay, so for the first question we've got standard form. So the first 3 are just simple questions. I'm asked to write a number in standard form. Just remember, to write any number in standard form, you write it as the number times by 10 to the power of something. So essentially I look at the digits and I turn them into a decimal. So 7.65, I know it needs to be times 10 to the power of something. And if you've got a decimal, as in if the number is a really small number, then it's going to be to a negative power. And the quick shortcut way is just count how many zeros there are before your number starts. So there's 1, 2, 3, 4, 5 zeros. So that would be 7.65 times 10 to the power of negative 5. With whole numbers, I'm going to similarly just look at the digits, turn them into a decimal, a 1-digit decimal, so only 1 digit before the decimal point, 5.698 times by 10, and then I count the number of digits that there are before the first digit. So 1, 2, 3, 4, 5, 6, 7 times 10 to the power of 7. Now I've got a number that's been written in standard form and I need to write it as an ordinary number. All that means is just as a number by itself. So 3.678 to the power of, oh, that should say times 10 to the power of negative 4. So to the negative 4 means I'm going to have 4 zeros before my number starts. So 0.000, and then I write my number 3678. And for the next question, I'm told to write 76 times by 10 to the power of 7 in standard form. Now some people might be like, oh, that's in standard form, but it isn't, because this number here needs to be between 1 and 9.9. Okay, so you need to turn this into a decimal, and in order to do that you divide this by 10, and because you've divided one part of the calculation by 10, you're going to need to multiply the other part of the calculation by 10 in order to keep it balanced. So that would be 7.6 times 10 to the power of 8. You can always double check it by actually working out the calculation, and you've got a calculator, so that should be pretty simple. So for this next question, it's a calculator paper, so literally just type in the question into your calculator. Be very careful, especially at the part where after you type in something with a power, make sure you use the arrows to move, to press next, otherwise everything would be done to the power of. Just check that it looks like how your calculation looks like and press equals. You're going to get a number that looks like this. Annoyingly, on this calculator you have to press format and then decimal in order to turn it into a thing. So once I've got that, it gives me the number 712,178.5714, and the question's asking me to give my answer to 3 significant figures. So 3 significant figures, I circle the 3rd digit and then I round, so that would be 712,000, because 1 is less than 5, so it rounds down. Next, I've got an addition. So once again, I could do this on my calculator, so just type in 3.8 times 10 to the power of 4 plus, or I'm going to just do it step by step actually. So 3.8 times 10 to the power of 4 is 38,000, and then 5.8 times 10 squared is 580, and then you add these two together, and the whole point is that you're going to get something that isn't in standard form. So that's 38,580, and then you just convert this back into standard form. So 3.858 times 10 to the power of 1, 2, 3, 4 times 10 to the power 4. So here we've got another slightly tricky one with standard form. The key is use your calculator, let it help you, and just be very careful when you're entering everything. So remember to press the shift button to get the upper things. So like the cubed root, for example, you'd press the shift button and then it allows you to put the cubed root in. So you put the cubed root, then you press your fraction button, and now a cubed, well, a has the value of 3.2 times by 10 to the power 4. So you enter that into your calculator, but you put it in brackets because the whole thing is being cubed. Okay, so the whole thing is being cubed, and then you divide that by 1.8 times 10 to the power of minus 3. Your calculator thankfully works that all out for you, and that would give you 263,062.6213. It says give your answer in standard form, so this is a bit of an ugly number in terms of it doesn't round nicely. So that would be 2.630626213 times by 10 to the power of 1, 2, 3, 4, 5. So remember the power of 10 is thinking about how big your number is. And even though we've got a decimal, the number continues here. So here we've got a best value problem. I'm told that Jenny is going to buy 20 litres of paint, and here's some information about the cost of paint from 2 different shops and which shop should she essentially buy it from. She wants to buy 20 litres of paint as cheaply as possible, so we need to figure out how much it's going to cost in both of the shops. So for prime paint, I know that 2 litres cost £21. And I know that she wants, how much? 20 litres. So if you just set up a little equation like this, you can use the unit method. So you just think to yourself, what do I multiply 2 by to get to 20? I multiply it by 10. So I do exactly the same thing on this side. Therefore, 20 litres is going to cost £210. There's no special offers, so that's just the price she pays for there. Then we can look at paint for less. So I know that a 5 litre pot, the normal price is £65, and I know that there's currently a sale which is 15% off the normal price. So I know that I can get 5 litres, and you can either work out the 15% first, so do 0.85 times 65 and then multiply it by 4, but I'm just going to work out the total cost and then subtract 15%. So no 5 litres is normally £65, and I want to figure out how much 20 litres is. So what do I do? Well, to get from 5 to 20, I multiply by 4, so I have to do the same over here. And 65 times by 4 gives me 260. So the normal cost over here would have been £260, but there's 15% off the normal price. And remember, as a multiplier, if you have 100% and you take 15%, you're left with 85%. And what does percent mean? It means divided by 100. So 85% as a multiplier is 0.85. So to work out like 15% off, just the quick way with the multiplier, we'd just do 260 times by 0.85, which is, times 0.85 is £221. So I would say she should buy from Prime Paint as it is £11 cheaper. Always, when you've got a question like this, you need to maybe even circle your answers just to show it, just to make it clear to the examiner where they are. £210 versus £221. So here I've got a scatter graph. I'm told that the scatter graph shows the temperature of a park in London and the number of ice creams an ice cream van manages to sell over the summer holidays. First question says that one of the points is an outlier, and I need to write down the coordinates of this point. So an outlier is literally, you're going to get all of your coordinates that roughly follow the same trend. So they're all going in the same kind of direction, they form a pattern. And then the outlier is the odd one out. So the outlier is over here, and let's have a look at what the coordinates is. So if that would be 27, I know that 5 squares make up 1. 1 divided by 5 is 0.2, so each of the little squares is 0.2. So that would be 26.8 as my x coordinate. And then my y coordinate, these bars seem to be going up in, actually, that might even be 26.7. Yeah, sorry, it's very small on my iPad. So 26.7, but you get a tolerance allowance. And then 131. So whenever you've got this, just be really careful with the scales, especially if it seems like an easy question. Just be very careful that whatever the distance is, you divide it by the number of squares, and then that tells you what each square is worth. Now give a reason for why the outlier may have occurred. Okay, so the general trend is that as the temperature rises, the number of ice creams sold rises too. So generally, the hotter it is, the more people go out and the more that they want ice cream to help cool them down. So why might, on a day of 26.7 degrees, which is quite hot, the van have only sold 131 ice creams? Well, I mean, there could have been a lot of reasons, but perhaps there may have been a festival or football on or something that meant people weren't out. So this is kind of like using your real life kind of application. So something that would cause people to not be out and wanting to buy ice creams. Or more likely, the van may have broken down at some point. So perhaps they were selling loads of ice creams and then the machine just stopped working and he had to go home. So anything that would have meant that it's unusual for him to have sold that few ice creams. Next question says, excluding the outlier, what is the relationship between the outside temperature and the number of ice creams sold? Well, as the temperature increases, the number of ice creams sold increases too. So this is a positive correlation. It means as one variable goes up, so does the other. Now the last part, and this is where people always seem to just get a bit lazy and just say, oh, I just know. It says, on one of the days, the ice cream van managed to sell 168 ice creams. Estimate the temperature on this day, and people just go to 168 and roughly say this is where it's going to be, which is great, except you're not going to get any marks for this. So if you see the word estimate, it means you need to draw a line of best fit. You absolutely have to draw a line of best fit. There's no two ways about it. Without a line of best fit, you get no marks, even if you're right. So line of best fit, it doesn't have to go through 0, 0. It literally goes through as many, and that's annoying actually because my pen is really thick, so that's not going to be helpful. Let's try and do it as thinly as possible. Okay, so it wants to roughly have as many points above the line as below, and it needs to be done with a ruler. So to estimate, what we do is we use our straight line. We go to 168. We go up to our line. Then we use that to figure out what the other value is. So that would be, I know that they're going up in 2, so that would be 26.2. And that, okay, so in this question, I'm told that the table shows the weight of 50 Cocker Spaniels. And I need to write down the modal class for the weight of the Cocker Spaniels. So the modal class literally means the class that contains the most amount of values. Remember, the mode is the most common, and modal is just the plural version of the mode. So the modal class, because it's a class, it's not just one value. So you look at the frequency column and you look for the largest value. So 15 is the largest value. Therefore, the modal class is between 9 and 12 kilograms. Then I'm being asked to find the group that contains the median weight. So to work out what the median is, the trick that you use is whatever the frequency is plus 1 divided by 2. And the reason for this, just really quickly, if we have 2 values, let's literally say 3 values. the median is the second value, okay? But if I did 3 divided by 2, because there are 3 numbers, if I did 3 divided by 2, that's 1.5. So it's a little trick that sometimes doesn't make sense to people, but to find the median, you do whatever the total is plus 1, and then you divide it by 2. And that tells you what the median number is. So 51 divided by 2 is going to be 25.5. So I need to find where the 25.5th value would be. So I know the first 3 values are here. 3 plus 8 is 11, so the first 11 values are here. 11 plus 10 is 21, so the first 21 values are here. And then 21 plus 15, well, that's going to give me 36. So I know, once again, that the median is going to be in this class here. So wherever your value lies, all of the values are cumulative when you add them all together, and that's how you find out where the 25th one would be. And then the last thing is to calculate an estimate for the mean. So this is the mean one. This is the one that requires a lot of work. So what you need to do, if it's a grouped frequency table, so this is a grouped frequency table because there are 2 values that it can lie between. And if that is the case, then you're going to just want to draw 2 extra columns for yourself. You don't have to, you can just work out what the midpoint is. But I'm just going to do that just because why not? So if it's a grouped frequency table, you have to find the midpoint. So the midpoint of 0 and 3, how do you find the midpoint? Add the values together and divide by 2. 3 plus 0 is 3, divided by 2 is 1.5. 3 plus 6 is 9, divided by 2 is 4.5. 6 plus 9 is 15, divided by 2 is 7.5. And then we've got 10.5, 13.5, and 16.5. That's the midpoint. And then the last column is going to be your midpoint times by the frequency. So I'm just going to use a calculator for this because it's a calculator paper. 3 times 1.5 is, I should have known that anyway, 4.5. 8 times 4.5 is 36. 10 times 7.5 is 75. 15 times 10.5 is 157.5. 12 times 13.5 is 162. And 2 times 16.5 is 33. So once you've done that, you find the total. Sorry. So to work out the mean from a group frequency table, you do the total of midpoint times frequency divided by the total frequency. So we find out what the total is here. So 33 plus 162 plus 157.5 plus 75 plus, is that 3.6? No, 36 plus 4.5 is 468. And the total frequency is 50. So 468 divided by 50 equals, 9.36. So the mean weight, an estimate for the mean, is 9.36. Okay, so here I've been given, well, I've been asked to draw a frequency polygon for the weights of the Cocker Spaniel. So the same table, just draw a frequency polygon for it. And the key thing with a frequency polygon is always plot against the midpoint. So that's the key thing to know that about a frequency polygon. Also, with a frequency polygon, when you've plotted your points, you join them together with a straight line like this. There's no line of best fit. You join from point to point to point to point. So first things first, I need to think of a suitable scale. So frequency is always going to be your y-axis, and the frequency goes up to 15. So I've got 1, 2, 3 large blocks, so that makes sense to do 5, 10, 15, and 0. Now my x-axis goes up to 18, and I've got 1, 2, 3, 4, 5 large blocks. So 20 divided by 5 is 4. So I could go up in 4s, but I would then want to think about it. If I go up in 4s, then 4 divided by 10 is 0.4. I suppose I could. So either you could go up in 0.4s, or you could just make your scale a little bit smaller and have it 5, 10, 15, 20. Actually, yeah, let's do that just to make it easier. Just because we're plotting against the midpoint. If you did it 0.4, that's absolutely fine. You just have to be a little bit more careful. So over here, we're going to say 5, 10, 15, 20. And I know that because each little gap is 5 divided by 10 is 0.5. So 1 square is half of a puppy. So let's start plotting. So remember, against the midpoint, so that would be 1.5. So 1.5 would be here, 1.5, and then 1, 2, 3. This is a lot easier when you're on paper. So 1.53 would be there. Then we've got 4.5 and 8. So 4.5 would be here, and 8 would be 9, 8. Okay, then we've got 7.5. So 7.5 would be nice and halfway. 7.5 and 10, that's a nice coordinate. Then we'd have 10.5 and 15. So 10.5 and 15. And then we'd have 13.5 and 12. So that would be 12.5, 13.5 would be here, 13.5, and then 12 would be there. And then 16.5 and 2. So 15, 16.5, 16.5, and then 1, 2. Okay, so I've plotted my points. Now I just join them together. I don't start from 0, I start from the first point. With a straight line, I join them boom, 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 in the order that they go. So just be very careful, and if you think you're going to forget, then join them up as you plot them. But that's essentially how you do a frequency polygon. So always a straight line and always plot against the midpoint. Okay, so here you've been given a lot of information, and generally when you're given a lot of information like this, you're going to want to do a two-way table. It doesn't tell you to draw a two-way table. You don't have to do a two-way table, but it helps with organising information. So I'm told that 70 people were asked if they would prefer to have a Cocker Spaniel, a Springer Spaniel, or a Sprocker Spaniel as pet. That is because Cocker Spaniels, any kind of Spaniel, is just the most loving, amazing, incredible pet you could have. So let's have a think. I know 70 people have been asked. I know there are 3 options, a Cocker Spaniel, Springer Spaniel, or a Sprocker. And I know that the people that were asked were children or adults. So I could form a two-way table. There's children and then there's adults, and they had the choices of picking from a Cocker Spaniel, a Springer Spaniel, or a Sprocker. And then with a two-way table, you always just want a total column as well. Sometimes it doesn't work out, so just add it on underneath. So with a two-way table, you can just organise your information so much simpler. So 70 people were asked. You know that your total is going to be 70. You're then told that 28 of the people asked were children, so you know that there's 28 children. And now, with the information that you've been given, you can figure out how many adults there must be. So 70, take away 28, is 42, because the children and the adults must add up to 70. You're then told that 15 of the 23 people who said Springer Spaniel, so where you use Springer, you know there's 23 in total, and that 15 of those were adults. So once again, 15 plus something must add up to 23. So 23 take 15, leaves you with 8. So in pink is all the ones that I'm working out just by elimination. And then in green is all the information that I've been given from the question. 2 children said they would prefer Sprocker Spaniel. So in the children, the Sprocker is 2. And now, if you can see, you've got all of this information here. You know that there is a total of 28 children. 2 of them said Sprocker, 2 of them said Springer. So therefore you can figure out what the last bit is. So 28, take away 8, take away 2 is 18. Obviously you don't need to do this. I just like figuring them all out anyway because it's fun. But you might not actually have needed that information. I haven't even read to the last bit of the question, even though I literally wrote this question a few hours ago. Okay, so next piece is 30 people said that they would prefer to have a Cocker Spaniel. So 30 people, so the total would be 30. And then you can work out any bits of missing information. That must be 12 because 18 plus 12 makes 30. The question says, one of the adults is chosen at random. Okay, what is the probability that this adult said that they would prefer to have a Cocker Spaniel? So one of the adults is chosen at random, so the probability is only going to be out of the total adults, and there's 42 adults in total. And then how many wanted a Cocker Spaniel? 12. So the probability would be 12 out of 42. Okay, next I've got some conversions. So here I'm being asked to change 6,000 centimeters cubed to meters cubed. And remember, when you're dealing with centimeters cubed and meters cubed, just draw yourself 2 little cubes. So 1 meter cubed is where you would have done 1 times 1 times 1, but 1 meter, the equivalent in centimeters is 100. So that would have been 100 times 100 times 100. So 1 meter cubed is actually 1 million centimeters cubed. So to get from centimeters cubed to meters cubed, we divide by 1 million. So I need to change 6,000 centimeters cubed to a meter cubed. So I'm going to divide 6,000 by 1 million. So 6,000 divided by 1 million is 0.006 meters cubed. Then I'm being asked to change a speed of 160 kilometers per hour to meters per second. So step 1, we know that 1 kilometer is 1,000 meters. So 160 kilometers, to go from kilometers to meters, I times by 1,000. So 160 kilometers times by 1,000 is 160,000 meters. So that would be 160,000 meters per hour that is being traveled. But I need to turn this into per second. So in 1 hour, I have 3,600 seconds. So to go from hours to seconds, now this is a little bit confusing because to go from hours to 10 hours to seconds, you multiply by 3,600, but they've traveled 160,000 meters in an hour. So I'm actually going to divide by 3,600. So divide by 3,600 is 44.4 recurring meters per second. So just try and think like logically what is happening. Next question is change 32 millimeters squared to centimeters squared. So once again, just draw yourself a square and think about it. 1 centimeter squared is 1 times 1, but 1 centimeter is equal to 10 millimeters. So 1 centimeter squared is actually 100 millimeters squared. So 32 millimeters squared, what do I do to go from millimeters to centimeters? I divide by 100. So 32 divided by 100 is going to give me 0.32 centimeters squared. And then for the next one, I've just got a calculation. So once again, use your calculator, press the shift and then the little cube root sign, press your fraction button, and then type in 1.34 cubed. Remember to use your arrow to move one across so that you're not having everything as the power, cos 40 over 6.5 to the power of 0.5. And then you would get 0.897505 going on and on it says the 3 significant figures, so we look at the third digit, so that'd be 0.898. So here I've got an exchange rate question. I'm told that in Cardiff, 1 litre of petrol costs 155.18 pence, so £1.55. And in New Orleans, 1 US gallon petrol costs $3.12. So I'm going to need to either convert my gallons into litres or my litres into gallons, and my pounds into dollars or my dollars into pounds. So I am going to probably stick to gallons. So I know that 1 US gallon is $3.127. Now I know that $1.27 is £1. So if £1 is $1.27, to get from dollars to pounds, I have to divide by 1.27. So I'm just going to divide this by 1.27 to work out what that cost is in pounds. So 3.127 divided by 1.27 gives me £2.46, or 2.46220, blah, 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 blah. But let's round that to £2.46. And that's in New Orleans. So now let's have a look at what's happening in Cardiff. So I know that 1 litre is £1.55, and I want to convert that into 1 gallon. Okay, so what am I going to have to do? I know that 1 gallon is 3.875 litres. So I'm going to have to times both sides by 3.875. So 3.875 times by 1.5518 equals £6.01. So therefore, in New Orleans, 1 US gallon is £2.46, and in Cardiff, 1 gallon is £6.01. So therefore, it is much cheaper in New Orleans, £2.46 versus £6.01 per US gallon. You could have done this and compared the litres, you could have done it compared in dollars. It doesn't matter as long as you've got 2 things that you compare it and you say which one's which. Okay, so here you are told that a square with sides of length x centimetres is inside a circle. Okay, so let's just roughly draw something. That doesn't look very nice. There we go. Inside a circle, each vertex of the square is on the circumference, that's why it's touching it. And I know that the area of the circle is 56. So how do I work out the area of a circle? Area is pi times by radius squared. So I know that 56 is pi times by radius squared. So if I did 56 divided by pi, that would tell me what the radius squared is. And 56 divided by pi is 17.825. That's r squared. So r is going to be the square root of 17.825. I don't need to write it all out. I can just type in the square root of answer on my calculator. Therefore, I know that the radius is 4.222008246. So I know that the radius is 4.22. So here is my radius, and let's think about what I can do. So I could create a diameter going from one edge of the circle to the other that also is the corners of the square. So therefore I have worked out what the diameter is, and the diameter is the diagonal of the square. So if I times the radius by 2, because the diameter is 2 times the radius, because if you think about it, that is your radius and that is also a radius, so 2 lots of it make your diameter. So the diameter is times by 2, 8.44016,491. Now, here is where I need to just do a little bit of kind of problem solving and thinking. So what do I know? I need to figure out what x is. So I could imagine that this is a triangle with a hypotenuse of 8.44. I missed out a 4 there. And it's a square, so the sides are all equal. So if this is x, this is also going to be x, and I can use Pythagoras. So I know that x squared plus x squared must equal 8.44 squared. Sorry, I don't know. I've got a bit of a cold and my voice goes sometimes. So because they are both the same, they're both x squared, and I can collect the like terms. So I know that 2x squared must be 8.44 squared. I could then divide by 2. So x squared is going to be 8.44 squared divided by 2. So let's actually just type that out on my calculator. So 8.44, or my answer, squared divided by 2 is 35.6507. And to figure out what x is, I'm going to do the square root of that, and I just type in my square root of answer. So square root of answer is 5.9708 to blah blah blah, but it says give your answer to 3 significant figures, so x is going to be 5.97, and that would be what the side length of the square is. Okay, so in this question, I'm told that a parcel in the shape of a cylinder is placed on a horizontal floor. So you could just visualize what's happening. So it's a parcel in the shape of a cylinder. The parcel exerts a force of 150 newtons on the floor and a pressure of 30 newtons per meter squared. The face in contact with the floor is a circle, so over here, with diameter x centimeters. And I need to work out the value of x. So let's first start by using the formula. I know that pressure is force over area. I've been given the pressure, I've been given the force. So actually what I want to work out is the area. So I can just rearrange it. And whenever you have like the subject and what you want to be the subject as a denominator, you can just switch them. So area is therefore force divided by pressure. So I can figure out what the area of the circle is. So the force is 150 and the pressure is 30. 150 divided by 30 is 5 meters squared. Now once again, what's the formula for the area of a circle? It's pi times radius squared. So I know that 5 is equal to pi times by radius squared. So if I just rearrange that, 5 over pi is the radius squared. And let's type that into a calculator. So 5 divided by pi is 1.591 is the radius squared. So the radius is going to be the square root of that. So square root of answer is, or 1.2615. And I've been asked to work out the diameter. So the diameter is going to be twice the radius, so times that by 2, which is 2.5231325 blah 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 meters. Now the question says give your answer to the nearest centimeter. So because I'm now working with linear measurements like length, not area or volume, I know that 1 meter is 100 centimeters. So 2.523 meters is going to be, just times it by 100, 252.313 centimeters, and it says to the nearest centimeter, so that would be 252 centimeters. Okay, so here I've got a box plot that shows information about the sales in thousands of pounds of Pet Shop A each month. Valentina says 1/4 of the given data lies between £150,000, which is here, and £400,000, because these are the values of the lower quartile and the upper quartile. Okay, so yes, she is correct. That is the lower quartile and this is the upper quartile. However, because of that, it means she's actually incorrect. So this is always going to be your lowest value, the little whisker of the diagram, and this is your max value. Then the lower quartile and the upper quartile are here, and this is your median. So essentially your data is split into 4 parts. First quarter is here. Second quarter is here. So between the lower quartile and the median. Next quarter is here, and the next quarter is here. So actually, no, she is not correct. 50% of the data lies between the lower quartile and the upper quartile. You could also have said a half of the data if you wanted to keep it in fractions, but essentially each little quartile is a quarter of the data. And so this middle bit here is the middle 50%, and it's called the interquartile range, and it's really useful because it tells us what's happening for the middle 50% of the data. Okay, so now I need to draw a box plot, and remember you've got every single box plot is going to look something like this, where this little part is your lowest value. This is going to be your lower quartile. This is going to be your median, then your upper quartile, and your maximum value. And this middle piece of data over here, so the interquartile range, what's happened there, is the upper quartile, take the lower quartile, and it tells you like the middle 50% of the data, and your total range is going to be your max value, take away your lowest value. So let's have a look at what I've been given. I know the least number is 120. So the distance between these 10 squares is 100, so each square must be worth 10. So 120 would be here. The lower quartile is 180. The median is 200. The upper quartile is 250. And the range, okay, so I haven't been given the maximum value, but I've been given the range. And how do I work out the range? It's the max value take away the lowest value. So I know that the lowest value, which is 120, plus the range, 230. So 120 plus 230 is 350. And that tells me what the maximum value is. So I can complete my box plot like that. And that's how I'd do that. You don't need to label them saying lower quartile and upper quartile and everything else, but just be mindful of the scale and double check it. Is the total range 230? Well, 350 take 120 is 230. So yep. Okay, so here I'm being asked to compare the distribution of the sales of shop A and shop B. Now, in order to do this, there are 2 things that you always want to compare when comparing distributions, and that is the median and either the range or the interquartile range. Because the median tells you the overall performance, and the range or the interquartile range tells you the distribution, so the spread of data, so how close together all the values are and how consistent they are. So first of all, let's see what the median is. So the median of shop A is 250,000 and the median of shop B is 200,000. So the median of shop A is higher than shop B, suggesting that overall shop A has higher sales. So the higher the median, the higher like the overall. We use the median to say what's happening overall. And then you could put your values, but just be very careful. So 250 versus 200, because if you put the wrong values, you actually can't get the mark. So if you're going to put the values, make sure they're the right ones. So that's the first thing. And secondly, we either compare the range or the interquartile range. The interquartile range is generally a little bit more accurate. So let's do that. So over here, that is 150 and that is 400. So the interquartile range of A is 400 take away 150, which is 250,000. And shop B, we worked out, well, we're going to have to work out again. So 250 is the upper quartile, take 180, which is the lower quartile, which is 70,000. So basically, the larger the range, the more inconsistent the data. So like one day you might be getting this, one day you might be getting that. So if you look at the box plot we drew for shop B, you can see that the middle 50% of the data is really clumped together, whereas here it's actually quite spread apart. So the interquartile range of shop B is a lot less, suggesting that the sales are a lot more consistent in shop B. So the spread of data is a lot smaller. The sale prices have a smaller range. And that's what we do to compare distributions, so median and either range or interquartile range. Okay, so polygons question, and polygons are super fun. So let's see what's happening. So I'm told that the diagram shows a regular pentagon. Regular is a key word because it tells me that it has equal sides and all equal angles. So that's really important because it means I can work things out. And two identical squares that are balanced to form a triangle. Sorry, my voice is just going. The side of square A that touches the top vertex of the pentagon over here is on the line of symmetry of the pentagon. So what that means is it splits the pentagon exactly in half. And I need to work out the value of x. Okay, so first of all, what I want to do is figure out what the angles in the pentagon are. You may already know this, but if you didn't, whatever the size of the polygon is, you just think to yourself, how many triangles can I fit in there? And you do that by putting a point on one vertex, one corner, and then you draw straight lines to each other vertex. So obviously that line just draws on top of an already existing line. Then I draw another line over here, another line over here to this one, and another line over here. So in total, how many angles are there in there? That's three triangles in there. And what do I know about triangles? I know that their angles sum to 180. So each of these little angles are going to sum to 180 each, and I've got 3 of them. So I do 3 times 180, which gives me 540. And this is the rule for any pentagon. However many sides there are, you take 2, because that tells you how many triangles there are. Okay, and this will work for absolutely anything if you use the rule I just told you. Start from one vertex and join them. So in this case, there's 3 triangles. I times it by 180, and I know that 540 is the total angles. Now, I've been told it's a regular pentagon, which means all angles are equal. So therefore, if all angles are equal, and there are 5 of them, all I need to do to work out one is 540 divided by 5, which is 108 degrees. So I know this angle here is 108 degrees. Now, what can I do? Okay, so I've been told that these are identical squares, which means this side and this side must be equal. So therefore I have formed an isosceles triangle over here. So that will probably be important. I know that this angle here is 90 degrees. And I also know that this is a line of symmetry here. So therefore, half of this angle, half of 108, is 54 degrees. So I could use that to figure out what this angle here is, because this is a straight line. So if you just visualized it like that, 54 degrees here, and 180, take 54 is 126. So I know that this angle here is 126. This angle, it's a square, so I know it's 90 degrees. And if I've worked that out, I can figure out what this angle inside the triangle must be, because angles at a point sum to 360. So I could either do well, you can do whatever you want. You could do 360, take away all of those angles, or you could do 180, take away 54, take 90, because these two angles here are on that. So I'm going to do that. 180, take 90, take 54 is 36 degrees. So I know this little angle there. Let's just draw that triangle a little bit bigger. So, this triangle here has an angle here that is 36 degrees, and it's an isosceles triangle, which means its base angles are equal. So this angle here is going to be 36 degrees, and I can use that to figure out what this angle here must be, because angles in a triangle sum to 180. So 180, take away 36, take 36 is 108 degrees. So I know that this angle here must be 108 degrees. These are my squares, so I know these two angles are 90. And once again, I've got angles at a point. So you could visualize it like that. So to work out what angle X is, you just do 360, take 108, take 180, because two lots of 90. So 360, take 108, take 180 gives me 72 degrees. So X is 72 degrees. Now it hasn't told you to give reasons, but if it did, then you would have just written down the reasons that I was saying. So like angles at a point, angles in a straight line, it's an isosceles triangle because the sides are equal and all of those things. Okay, so here we've got a question where we're dealing with a negative scale factor and a fractional scale factor, although it's written as a decimal. So the difference between a negative and a normal scale factor, first let's plot the center of enlargement and it will make more sense. So the center of enlargement is 5, 6. So 5, 6 is over here. Now, if you're just ordinarily like enlarging something by, let's say, scale factor 2, what you would do is you would count the squares from the center of enlargement to your shape. So let's just say that's 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3. Let's say we're enlarging it by scale factor 2. What you would do is you'd double those distances. So it would be 14 and 6, and then you'd plot your new point. So for normal enlargements, you go from the center of enlargement to your shape. But with a negative enlargement, it reverses the direction, and you actually start from the shape and then go towards the center of enlargement. So let's try that. So this is my first coordinate. I want to see how many squares I go across and up. So I go 1, 2, 3, 4, 5, 6, 7 squares across, and then 2 up. And what I need to do is I need to multiply that by 0.5. So that would be 3.5 across and 1 up. So from the center of enlargement, that's what I do. 3.5. So 1, 2, 3.5, and then 1 up. That is where that coordinate would be. Let's try it with the next coordinate. So that's the next vertice. So how many do I go across? I go 1, 2, 3 across, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares up. So once again, times that by 0.5. So I'd go 1.5 across and 5.5 up. So from the center of enlargement, I go 1.5 across and then 1, 2, 3, 4, 5.5 up. So that would be there. Oh, and that was a circle. And then let's do it with the final vertice. Let's just do that as a square. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 across in order to get to your center of enlargement. And then you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up, which is obvious because the other corner is also there. So I'd be going 5.5 across and 5.5 up from the center of enlargement. So here's my center of enlargement. I go 1, 2, 3, 4, 5.5 across, and then 1, 2, 3, 4, 5.5 up. So that is where that would be. And then you just join them together like that. So in the exam, it's not going to be like as annoying, hopefully. But essentially, when you have a negative scale factor, it flips the what's it called? The shape on its side. There are other ways that you can do it, which is using like the line method, but this is the method that I prefer. Okay, so we're dealing with compound interest. So Shadow invests £35,000 in an account paying compound interest for 5 years. And all compound interest means is that essentially whatever you have made on interest at the end of the year, that gets reinvested. So you're actually earning interest on all of the money that you've earned, including the free money you've got from the interest. So it's a really great way of growing your money if you can find an account with a good interest rate. So in the first and second year, the interest rate is X%. I don't know what it is, but I know that at the end of the second year, the investment is £40,825. So 35,000 times by, and let's say that the multiplier is Y, because I don't want to get confused with X. So Y times by Y is 40,824, because whatever the interest rate is, the multiplier, that would be entailed in Y. So the multiplier, let's say the interest rate was 3%, the multiplier would be 1.03. So X is 3%. I'm not calling it X because it might get a bit confusing. So I'm just calling the whole multiplier Y. And that will be easier to work out the interest rate. So I know that 35,000 times by Y squared is 40,824. So Y squared must be 40,824 divided by 35,000. So let's type that into my calculator. 40,824 divided by 35,000 is 1.1664. So therefore Y is going to be the square root of that. And the square root of answer is 1.08. So I know that my multiplier is 1.08, which must mean that the interest rate, X, is 8%. Okay, so that's why I didn't want to get confused between the multiplier and the interest rate. That's why I called it Y. So I know that the interest rate for the first 2 years was 8%. It then says in the final 3 years, the interest rate is X over 2%. What is the value of the interest that he has earned by the end of the 5 years? So if the interest rate was originally 8%, X divided by 2 is 4%. So at the end of the second year, he's got £4,824, and that's invested for year 3, year 4, and year 5. So I'm going to times it by 1.04, times by 1.04, times by 1.04, which you could obviously write as 1.04 cubed, but just to show you how you break it up in the years. And that would give me 40,824 times by 1.04 cubed is £45,921.45. I've just rounded it. But read the question carefully. It says, what is the value of the interest that Shadow has earned by the end of the 5 years? So if he invested £35,000, then we're just going to subtract that. So 45,921, take away 35,000, and my answer is saved, so I'm not just entering that, I'm just writing it so that I'm not wasting time, even though I just wasted time telling you. Anyway, answer, take away 35,000, gives me £10,921.45. And that is an excellent interest rate if you can ever find any bank account giving you 8%. Easy way to make great money. So in this first question, I'm just being asked to expand and simplify. So that's what I do. I multiply everything. Remember, when you're multiplying surds, you can treat it like algebra. So you could imagine that's the same as saying 3 times 2x, which would be 6x. So that would be 6 root 2. 3 times 4 is 12. And then minus 8 times 4 root 2. Again, imagine it is algebra. So minus 8 times 4x would give you minus 32x, but it's root 2 instead. And then minus 8 times by minus 5 is going to be plus 40. And then you add on 3 root 2. So because you can treat it like algebra, if you were to say 6x plus 12 minus 32x plus 40 plus 3x, how would you simplify that? Well, 12 plus 40 is 52. And then you've got minus 32x plus 3x plus 6x. So minus 32x plus 9x, which is going to be minus 21x. I think my brain is very tired, so let's just double check. 32 take away 9, it's 23. That's why it's important to double check. So 52 minus 23x, except this is not algebra, it's surds. So instead of the x, you just write 52 minus 23 root 2. I just showed you the algebra way just to show that if you panic in the exam, turn it into algebra and then the same rules apply. So that would be 52 take 23 root 2. Next, we've got this nice little algebraic fraction. So what you can do is think to yourself, that's the same as saying 13 times by x minus 3 times by x minus 3 times by x minus 3 over x minus 3 times by x minus 3. If you can't see it automatically, just split it up into its basic algebra. And then you know that if you've got a fraction and the numerator and the denominator are both products, so there's no like in between terms, everything is being multiplied, then anything that's on the top and the bottom cancels out, because like 5 divided by 5 is 1. So therefore x minus 3 over x minus 3 is also going to be 1. So that cancels with that, gives me 1. That cancels with that. And at the bottom, you're just left with 1. So that would be 13 x minus 3 over 1, which is just 13 x minus 3. And you can leave it like that because generally being factorized is its simplest form. Okay, for the next part, we've got this algebraic expression to the power of negative 3 over 2. So when it's a negative, either you figure out what it is and at the end you just switch it over. So basically, if you see a negative, it means it's reciprocal. So like, for instance, 8 to the power of minus a half or minus a third, that would be 1 over 8 to the power of a third, which is 1 over the cubed root of 8, which is 1 over 2. So if you had worked out 8 to the power of a third, which is 2, at the end, instead of doing this, you could have just flipped it. So that's the method we're going to try now. We're just going to ignore the negative for now, but know that at the end, I'm going to need to do its reciprocal, which is flipping it. So I've got 4x to the power of 4, y squared, to the power of 3 over 2. Now with fractional indices, remember that this is the denominator tells you what root it is, and the numerator tells you what power it is too. So each of these things are being rooted. So we've got the square root of 4 times by the square root of, okay, so basically, I think the easier way, yeah, so let's just do it all in one go. So split everything up, remember that it's being multiplied. So you'd have the square root of 4 to the power of 3 times by x to the power of 4 to the power of 3 over 2 times by y squared to the power of 3 over 2. So we can do these all one by one. So that square root of 4 is 2, and 2 cubed is 8. And then x to the power of 4 times by 3 over 2, that would become 12 over 2, which is 6. So that would become x to the power of 6. And then y squared is being times by 3 over 2. So multiply the fractions, because remember in brackets, the law of brackets is you multiply the indices. So 2 times 3 is 6, divided by 2 is 3. Okay, so that is what that would be, but it's the reciprocal. So all I do is, the final step is 1 over 8x to the power of 6 y cubed. Okay, so here I've been given a trapezium and its lengths have been given in third form. So let's just recap on the area of a trapezium. The area is a plus b times by the height divided by 2. And remember that a and b, they are the two parallel sides. So you can generally identify them. Actually, this should have a little thing. They will be kind of obvious because they would have the little parallel lines, and this should have done. So the two parallel sides, and then you times it by the height. The height is always the vertical height, so the perpendicular height. So if you're ever given the slant height and the vertical height, sometimes they do that just to confuse you. Always know that it's the perpendicular height, which means it meets at right angles to the base. So like that and that meet at right angles. So you know that's the square root of 3. So let's do that. So a plus b. So this is a and this is b. It doesn't matter which one's which because you're just adding them. So 2 plus root 3 plus 4 plus root 3 is then going to be times by root 3, and then I'm going to divide everything by 2. So let's simplify that. 2 plus 4 is 6, and root 3 plus root 3, remember you can treat it like algebra, x plus x is 2x, so that would be 2 root 3. And this is then going to be times by root 3, and then I'm dividing everything by 2. So root 3, let's put it like a bracket like that. Root 3 times by 6 is just going to be 6 root 3. And root 3 times by, this is where it's a little, hopefully you remember that a third times by itself is its unsurd self. So root 3 times by 2 root 3, that's the same as saying 2 times root 3 times by root 3. So this is just going to become 3. So that's the same as saying 2 times 3, which is 6. So I'm left with 6 root 3 plus 6 over 2. And all I need to do is divide everything by 2. So 6 root 3 divided by 2 is going to give me 3 root 3. And 6 divided by 2 is 3. And you've got that in the form a root 3 plus a, where a is 3. Okay, so a pet shop has 5 Cocker Spaniel puppies, 7 Ragdoll kittens, 9 Scottish Bluefold kittens, and Jada is going to choose one of the following combinations for her new pets. So she's either going to choose a Cocker Spaniel puppy and a Ragdoll kitten, so either one of the 5 Cocker Spaniels and one of the Ragdoll kittens, so in total that would be 35 combinations. Or she's going to choose a Cocker Spaniel and a Scottish Bluefold, so that would be 5 times 9, which is 45. Or she's going to choose a Cocker Spaniel puppy, there's 5 of them, a Ragdoll kitten, 7, and a Scottish Bluefold kitten, 9. So 35 times by 9 is 315. Show that there are 395 ways. Well, if I just said 315 plus 45 plus 35 equals, hopefully, 395. So remember the rules with probability. If it's something and something happening, you multiply. And if it's something or something, then you add. So the and rule is you multiply, the or rule is you add them. And that's why over here when I'm looking at my combinations, I'm multiplying because I have 5 little puppies, 1, 2, 3, 4, 5. And each of these could be paired with any of the 7 kittens. And so that's why I do 5 times 7. And similarly 5 times 9 and so forth. So yeah, that's how I do my combinations. So another slightly unrealistic thing, because Even if a dog did have a safe, I don't think they'd have the dexterity to open it with their large paws. But this actually happened to me when I was traveling. And it took me a very, very, very long time to open my backpack that had a lock on it. So Shadow forgets the combination for his puppy safe. There are 4 digits, okay, so there are 4 digits on the safe, and they use the numbers 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm writing these out because the amount of people that get questions like this wrong because they think there's only 9 options. If it's the number 0 to 9, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 options. So there are 4 digits that use the number 0 to 9. He remembers that one of the digits is a prime number. Okay, so what are the prime numbers? Remember, prime numbers are 2, 3, 5, 7, 11. So 2, 3, 5, or 7. So that's 4 options that one of the digits could have. And that the other is a square number. So what are the square numbers? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so forth. So that would be 1, 4, and 9. That's 3 options. And for the others, I'm going to have 10 options, okay, because it could be any of those numbers. And obviously this number could be here, this number could be there, but it doesn't matter because it's just the amount of combinations I'm looking at. So the total number of combinations for the safe are 4 times 3 times 10 times 10. So 4 times 3 times 10 times 10 is 1,200 combinations. And yes, my fingers and thumb were very, very sore after that. And yes, it was 9999, which I obviously should have tried first. It was a big mistake that you learn from. So what's the maximum number of combinations Shadow will have to try before he can unlock his puppy safe? Well, the maximum number would be 1,200 if he is unlucky, like I was, and it's the last possible option. Okay, so here we've got a few rearranging formula because it can come up in so many different ways. So rearrange to make X the subject. The first thing you want to do, if something is affecting every part of one side of the equation, then that is what you want to get rid of. So the whole of this fraction is being cube rooted. So the first step is to cube both sides. So y cubed would be equal to x to the power 4 plus 3 over 7. Then we've got it into a nice little fraction and we can just do what we normally do. Because x is stuck up here, we can't do anything, we can't move anything up here. If something's in a fraction, you have to first eliminate the denominator before you can touch anything on the numerator. So everything is being divided by 7, so we times both sides by 7. So that would be 7y cubed equals x to the power 4 plus 3. Then what do? We take 3, so that would be 7y cubed take 3 equals x to the power 4. And then the final part is you're going to want to do the root 4 7y cubed take 3 is going to give you x. So you're always, just to move anything from one side of the equation to the other, you just do the inverse. Over here we've got another subject of the formula. So you've got 2 terms that have x in it. So what you want to do, if you've got 2 terms that have x in it, bring them both to the same side, and then you're going to want to factorize. So let's move everything around. So you've got 8x minus pi x. I'm going to take pi x from both sides, and at the same time I'm then going to add 7 just to make it a little bit quicker. So that would equal 4y plus 7. You could have done it in 2 steps if you prefer. So now I've got both of my x terms on one side. What I can do is factorize it so that I just get x on its own. And then if I factorize that, I just have one lot of x, and I can divide both sides by whatever's in my bracket. So if you divide both sides by 8 take pi, you're left with x equals 4y plus 7 over 8 take away pi. And there you've rearranged it. Okay, so another rearranging. So I've got x as my denominator. So the first thing I want to do is multiply both sides by x to get rid of that as a denominator. The next thing I can do is expand my brackets. So yx equals 8a minus 16x. And remember that when you've got two terms that contain the thing you want to make the subject, you want to put them on the same side, because then you can factorize them. So I'm going to bring over 16x equals 8a. And then I've got two terms with x in it, so I can factorize the x out. So that would be xy plus 16 equals 8a. And therefore, the final step would be to just divide both sides by the bracket. So 8a is y plus 16. So let's try that with a slightly harder one. Same principle though. So times both sides by the denominator, because that's what you want to do so that you don't have a fraction. So y multiplied by x minus 2 equals 4x plus 3. We're going to have to expand this because x is the term that we want. So yx minus 2y equals 4x plus 3. Remember that you're going to want both of your x's on one side. And I'm going to move the y over here because otherwise everything's going to be negative. Remember, you can play around with things, moving them from one side to the other as much as you want. It doesn't matter as long as you're doing the inverse operation. So yx equals 4x plus 3 plus 2y. Then if I subtract 4x, I'm left with yx minus 4x equals 2y plus 3. Now I can get to the point of factorising. So x is going to be y take 4. So all I've done is I've factorised x out of it. So that is over here. And then the final step, just divide by the bracket. So the key thing here is everyone seems to find these things a little bit tricky, but all you want to do is when you've got a complicated thing like this is jiggle things around, move things from one side to the other. Eventually you're going to get two terms that have x or y or whatever it is that you want to make the subject. You just bring them together on the same side, factorize it, and then divide both sides by the bracket, and then it's your subject. Okay, so here we've got quite a tricky question involving bearings. So the first few things that we need to really bear in mind when dealing with bearings is that we always start from due north. So all bearings, you're always going to see this little due north sign. And we always start measuring it from north so that when we're communicating with bearings, we know like in what relation it is to. So always start from due north. You always go clockwise. You always write them as 3 digits. So if the angle you found was, let's say, 52 degrees, you would write that as 0,352. And the last thing is that you always start from where it says from. So these are the key things that we need to know. If bearings are a little bit confusing, then just watch the full video that I've done on bearings where I explain through it a little bit more slowly. Now, sometimes it's not just going to be bearings you're going to need to use, it's going to be trigonometry as well. And if it's something that looks like this, likely that's going to be the case. So the cool thing about bearings is that they are always, like I said, you always start from due north. So let's just imagine it's a simple bearing where you've got a ship here and a port here. Now what we do is we have our two bearings, like literally this point here is where the ship is, this point here is where P is. And what we can do is draw a bearing going up north. So draw our little up north sign and just draw a line connecting the two bearings. Now, if I wanted to work out the bearing of the ship from the port, what I do is I start from due north, I go clockwise until the line, and this would be the bearing. So let's just say that's, I don't know, 280 degrees. So the bearing of the ship from the port would be 280. However, if I wanted to work out the bearing of the port from the ship, then I'd start from here and I'd go clockwise. So it would be this bearing here. So that's just something to bear in mind. But let's apply it to this question here. So I've got 3 towns, Branton, Cordon and Dorringford. And I know that Branton is 7 kilometres from Cordon on a bearing of 41 degrees. And that Cordon is 9.5 kilometres away from Dorringford on a bearing of 160 degrees. So that's all the information that I know. Now, using bearings is always going to be really helpful if you just use your knowledge of parallel lines first, especially if you don't know where to start. So over here, I've got my due north sign. Over here, I've got another due north sign. Therefore, these two lines are parallel because they are both just straight up north. So using parallel lines, I know that when angles are on the inside of the parallel lines, they are called co-interior angles, and they sum to 180 degrees. So therefore, I can figure out what this angle here is by doing 180, take away 41, which is 139 degrees. So I figured out just that little bit of angle there. When you get a complicated question like this, you're always just going to want to problem find, like a little hunt for anything that you can get. You don't, well, I never start where it's asking me to. I always think, what can I figure out from the question already? What else can I do? Well, I know that this over here is a point, and I know that angles are points sum to 360. So I could figure out what that angle there is by doing 360, take 139, take 160, which leaves me with 61 degrees. So these are just the easy angles that I can find out before I've even looked at the rest of the question. Now, I want to find the bearing of Dorringford from Branton. Now remember, that's the key word that we need to look out for. So we start from where it says from. So first things first is I want to draw a straight line from bearing, what was it called, Branton to Dorringford. So essentially, I'm just going to get rid of all of this. Essentially what is happening is this is the bearing that I need to work out. So I'll just draw it separately here. So this is Branton, and this is Dorringford. Okay, and this is what it would look like if it was just one bearing. And I need to work out this angle here, which would be all of this. So in order to do that, I have formed a triangle here, and I know this angle here is 61 degrees because it's over here. I know this side here is 7 and this side here is 9.5. So I am going to have to use some advanced trigonometry to help me work the next steps out. So I've got two sides, one angle, and the trick is to, when you're using the sine rule, you want to have two sides and their corresponding angles, one of which you want to find out. But essentially you want two sides and two angles, and one of them can be missing, but it needs to be corresponding. Whereas here, if I just labeled this triangle, let's label this big A and this little a, and this would be little b. So this here would be big B, this C, and this would be big C. I don't have the corresponding angles for anything apart from A. So if you only have one angle and its corresponding side, then you're most likely going to use the cosine rule. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos A. It's also on your formula sheet though, so you don't need to worry about memorizing it. And all this means is a little letter, it represents a side, and a big letter, it represents an angle. And you can label your triangle however you want. A, B, and C, if they've labelled the triangle A, B, and C, but you want a different angle to be A, that's absolutely fine. Cross out what they've written and you relabel it the way you want to. So I know that B is 9.5, C is 7, and big A is 61. So to work out the length of this side here, which is what my bearing of BD is on, I would do 9.5 squared plus 7 squared, take away 2 times by 7 times by 9.5 times by cos 61. So A squared is going to be, and I always tend to do the calculation in two parts. So I do 9.5 squared plus 7 squared, just because it minimises accidental errors on the calculator. So that's 139.25. And then 2 times 7 times 9.5 times cos 61 is 64.47 96, but I don't need to write it all out because it's memorized on my calculator. So a squared is going to be 139.25. Oops, I'm supposed to be typing that into my calculator. 139.25, take away answer. So your calculator automatically memorizes the last thing that is that it calculated, so you can just use that as a shortcut. So take away answer is 74.7703 blah 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 blah, and a is going to be the square root of this. So a is square root of answer, which is 8.646. So I'll just rub this out so that there's room for it. Actually, I'm going to write it out here just in case I need the full for later. So 8.646983318. Okay, so this is the length of this side here. Now, once again, I've got the same triangle, and the thing is, because it's a tricky question, and a question similar to this appeared as like the last question on one of the papers, so this is not an easy question, but I just wanted to throw it in there because it's important. So let's have a look at what we know now. We know that this is 61. We know this is 8.64. We know that this is 9.5 and that this is 7. And this here, this angle here, is the angle that I'm after, because if I know what that is, I can work out what the bearing is. So let's label it again. We can keep this as it was. I can't remember if this was little b or big B, but it doesn't matter. So, and with the sine rule, there are two options. You can either write a over sine A equals b over sine B, or it can be sine A over A equals sine B over B. Now this option, and once again these are on your formula sheet, is best if you are finding a side, and this option is best if you are finding an angle. And the reason for that is because you essentially want whatever you're finding to be the numerator of the fraction, because then it's less rearranging. But on it, you can actually use either, it's just a bit more rearranging. But it's just a helpful hint to know. So I'm trying to work out the angle, so I'm going to use the second version where the angle is on top. So sine A over A is equal to, I'm supposed to be substituting, so sine 61 over 8.64 is equal to sine B, which I don't know, it's this here, over 9.5. So therefore, if I multiply both sides by 9.5, sine B is going to be equal to, so sine 61 over 8.64 times by 9.5 is 0.96167, and so forth. Remember, I'm going to save this as my answer, so I don't need to write everything down. So therefore, the value of angle B is going to be the inverse. So I press shift, sine, and then answer. So shift, sine, answer, and that tells me that angle B is 74.0865, so forth, degrees. So I need to work out this bearing of Dorringford from Branton, strange names. So therefore it's going to be this angle here. Remember, you start from due north, you go clockwise until you reach the line, and your bearing is going to have to be 3 digits. So 74.0865 plus 41 is 115. 0.086506, that's the angle. Now it's saying give your bearing to 1 decimal place, which I will do just now. So I know that this angle here is 115.086506, so therefore the bearing to 1 decimal place is going to be 115.1 degrees. And yes, a slightly tricky one, but basically if you have something that looks complicated and looks like you could form a triangle, you're going to use the sine and the cosine rule. So just see what you can substitute, see what you can figure out, and you will get somewhere. Yes. Okay, so Willow wants to work out an estimate for the total number of hummingbirds in a nature reserve. Now this is the capture-recapture method, and essentially it's saying that if you catch, so let's say on day 1, you catch the number, however many you catch on day 1, over the total population is going to be an equivalent fraction to if you then on another day go out and, so basically with capture recapture, you capture a certain amount of, in this case, hummingbirds. So let's say on the first, well, actually let's do it. So on Saturday she catches 35 hummingbirds, okay, marks each of them and then releases them back into the wild. So the idea is that these 35 birds are representative of the whole population. So 35 over the total population, to estimate the population, I make it equal to what I then capture on my second day. So the idea is that on the next day, you catch a certain amount. So in this case, she catches 72 hummingbirds, that's the total. And 6 of these are tagged. So the idea is that the proportion of tagged to untagged is going to be equal to the proportion of the ones she caught out of the total population. So that's how we use the capture-recapture method. And in order to work out the total population, we can just call that X and then just rearrange everything. So in order to, so if you were just solving this like in an equation, what would you do? You times both sides by X. So 35 would be equal to X times by 6 over 72. And then to get X on its own, what would you do? You divide both sides by 6 over 72. So therefore 35 divided by 6 over 72 equals X. And 35 divided by 6 over 72 is 420. So that would be an estimate. Another way you could do it is you could have said 35 over X equals 6 over 72. So you could have thought to yourself, okay, what's 35 divided by 6? That is 5.83 recurring. So 35, so 6 times by 5.83